We're graphing polynomial functions in this screencast. I also want to talk about the intermediate value theorem. So to begin with, we want to talk about are the zeros and turning points of a polynomial function. So here's the definition. If p of x is a polynomial function of degree n, then the graph of the function has at most n real zeros and at most n minus 1 turning points. So understand what this is saying. If you have, for example, some function p of x, which is a degree of 4. So suppose the degree of function p of x is 4. Then it has at most 4 real zeros and at most 3 turning points. It's best if we look at this with a specific example. So here's a specific example. F of x is equal to negative x cubed minus 3x squared plus x plus 3. So what we need to know is the degree of this function, which you should understand from previous screencasts that the degree of this function is 3. And by the definition on the previous screen, if the degree is 3, then there are at most 3 zeros. And then there are at most 2 turning points. Let's look at the graph of this function and see how it relates. So here's the graph of negative x cubed minus 3x squared plus x plus 3. This function actually has 3 zeros, and those zeros are here, here, and here. And this function actually has 2 turning points, and the turning points are here and here. So the zeros are in red and the turning points are in green. Okay, now switching focus. We're going to talk about the multiplicity of zeros. So I want you to consider the function f of x equals x minus 3 squared. This is a quadratic function. And you should know from last chapter what this would look like if we graphed it. It's the graph of x squared shifted 3 units to the right. Looks like this. Now, the degree of a quadratic function is 2. So a quadratic function has at most 2 zeros. Now, we know from this graph, and we know from the previous section, that there is only one x-intercept for this specific function f of x. This specific function has 1 zero, and it's at 3. And the multiplicity of that 0 is 2. So understand where that comes from. See this power on this factor of x minus 3? So the 0 is positive 3. The multiplicity of that 0 is 2. Now look at how the multiplicity affects the graph. When the multiplicity is 2, when the multiplicity is even, the graph comes down to that x-intercept, comes down to that 0, and then bounces right back off. So when the multiplicity of a 0 is even, the graph bounces off the x-axis. Now let's look at an example where the multiplicity is odd. So here's a different function. F of x equals x minus 1 cubed. That's the graph of x cubed shifted 1 unit to the right. Looks like this. A cubic function has a degree of 3, so it has at most 3 zeros and 2 turning points. This specific function only has 1 zero, and the multiplicity of that 0 is 3. Now, what happens when the multiplicity is 3? In general, when the multiplicity is odd, well, the graph goes through the x-axis at that 0. It's summarized here. When the multiplicity of a 0 is odd, the graph goes through the x-axis. Okay, so let's put that all together in this next example. Consider the function f of x equals x times x plus 2 cubed times x minus 1 squared. First, we want to think about the degree of this function. Now, this is the first time we've had one written in this form. The degree of this function is 6. Make sure you understand why it's 6. You're going to actually multiply these powers of x together. So it's x to the first times x cubed times x squared. So add all those exponents together. 3 plus 2 plus 1 is 6. Now, what's the graph of a polynomial function of degree 6 look like? Remember from our leading term test, the leading term is x squared. The coefficient is 1 and it's positive. So if the degree is even and the leading coefficient is positive, it's going to have that U shape. Okay, now what are the zeros? The zeros are 0, that comes from this factor, -2 comes from this factor, and +1 comes from this factor. Now, what's the multiplicity of those zeros? Well, the multiplicity of the 0 at 0 is 1. The multiplicity of the 0 at -2 is 3. And the multiplicity of the 0 at 1 is 2. Are you catching on to where those multiplicities are coming from? Now, what about the graph? If the multiplicity is odd, remember the graph is going to go through the x-axis. So that would happen here and here. And if the multiplicity is even, it's going to bounce off. So what happens at the x-axis is at this 0, it's going to go through because the multiplicity is odd. It goes through at -2 because the multiplicity is odd, and it bounces at 1 because the multiplicity is even. So if I wanted to sketch a graph, okay, and I'm not talking about on your calculator, I'm talking about with what the information I have right here, the information in front of me, what I know about this function, I want to draw a sketch of this graph so I know approximately what it's going to look like. This isn't exact, but it's a pretty good sketch. The first thing I'm going to do is I'm going to graph those 3 x-intercepts. The x-intercepts are -2, 0, and 1. Remember, those are the zeros. Then I want to think about this shape. And I know it's going to have this U shape. So my graph is going to start up here in the second quadrant and end here in the first quadrant. Remember, it's going to have that general U-ish shape, if you will. So the next thing I'm going to do is I'm going to draw a sketch of this. And I'm going to think about what's happening at this 0. At the 0 at -2, remember I'm going through. At the 0 at 0, we're going through and bouncing at the 0 at 1. So I have a rough sketch that looks something like this. Now this by no means is exactly what the graph looks like. I don't know how low this minimum is, and I don't know how high that max is. You'll learn that in calculus. But I have a general idea of what that shape is going to look like. Now, if you graph that in your calculator, you'll see we're pretty darn accurate. And here's what the actual graph of the function looks like. Please pay attention. It goes through the x-axis at -2, through at 0, and bounces at the x-intercept at 1. It has that general U shape because the lead coefficient is positive. It's a U-ish shape that's facing up. Okay, the next thing we're going to do is turn our attention to the intermediate value theorem. Let me give you a general explanation of what this is saying. So if you have some bridge and there's a person on this side of this stream, on this side of the bridge, and then you turn your head and the next time you look, the person's on the other side of that stream, then you know that the person had to have crossed the stream to get there, maybe going across the bridge. That's basically the idea here. So, for example, if I have some function and I don't know what the function looks like, but I know that the value of the function at 0 is 4, and the value of the function at 1 is -3. If this is a polynomial function, then the graph has to, at some point, if it's going to get from 4 to -3, it has to pass through that x-axis. How do I know that? I know that because the signs change. Because there is a sign change, there has to be a place where, and that place would be C, where f of C is going to be equal to 0. And that value of C has to be between these two numbers, 0 and 1. Here's the actual graph of this function. So at 0, we're at positive 4. At 1, we're at negative 3. And somewhere between 0 and 1, we cross through the x-axis. And that means that there's a 0 right here, which is between 0 and 1. Here's the formal definition of the intermediate value theorem. For any polynomial p of x with real coefficients, suppose that for a not equal to b, p of a and p of b are of opposite signs. Then the function has a real 0 between a and b. That's what I illustrated on the previous screen. Now I want you to read the second sentence with me. The second part of this says, the intermediate value theorem cannot be used to determine whether there is or is not a real 0 between a and b when p of a and p of b have the same sign. So if they have the same sign, I don't know what's happening. I can't say there isn't a 0, but I can't say that there is. So let's look at an example. Consider the function f of x equals x cubed plus 3x squared minus 9x minus 13. Determine, if possible, if there is a 0 between negative 5 and negative 4. To do this using the intermediate value theorem, I have to know what f of negative 5 is and f of negative 4 is. Go ahead and plug those into the equations. Pause the video if you need to. And you should get as your answers negative 18 and positive 7. Because there is a sign change, I know there is at least one 0. I don't know how many, but I know there is a 0 between negative 5 and negative 4. Okay? Try two other numbers. Determine if there is a 0 between 1 and 2. So plug 1 and 2 into that equation. When you plug in 1, you get negative 18. When you plug in 2, you get negative 11. Because there is no sign change here, it cannot be determined using the intermediate value theorem. I really just don't know. So now that we've used that intermediate value theorem, let's actually graph this function and graph it in your calculator. And once you get it graphed in your calculator, I want you to pull up this table. To pull up the table, you're going to, on your graphing calculator, press second and graph. That pulls up the table. And you should be looking at what I'm looking at. Now, what I'm looking for in this Y column are sign changes. So where does the graph change from being negative to positive? We already identified that there is a 0 between negative 5 and negative 4. We did that on a previous screen. Now, where else is it going to happen? Well, it happens here between negative 2 and negative 1, and it happens here between 2 and 3. The intermediate value theorem isn't telling me what the zeros are. It's just telling me because there's a sign change here, there must be a 0 in between these two numbers. So this polynomial function has 3 zeros, and I don't know what those zeros are, but I know they're between negative 4 and negative 4, negative 5 and negative 4, negative 2 and negative 1, and 2 and 3. All right, that's a lot of information. Good luck. Email me with your questions.